This will become plus, and lambda will be minus because you're taking it over the other side. And then divide both sides by a of k, so you'll get this and this. Now, now for alpha is 0, so these alphas here disappear. You just get this simple equation. But that's true for alpha is naught. But we have two possibilities for alpha. Alpha could be naught or could be 1. Right? Now if alpha is 1, this term here, this ratio, ak plus 2 over ak, so you've now got alpha's 1 here. So you'll get k plus 3 times k plus 2. So you divide that, here it comes underneath. And here you've got k plus 1, k plus 2, minus lambda. Right? So, so what have we got here? We have now a kind of recursive relation, a recursion relation. So, if we know what AK is, given these two formulas, so if we know what AK is, we can find what AK plus 2 is. Right? Now we know what A naught is, right? So we should be able to find what A2 is. And so that way we can ratchet up. Now, how to find what A1 is. So how good question. So if we know what A1 is, then we know what A3 is. So how to find A1? I'm just thinking on my feet. Well, thinking in real time here. How to find what A1 is. So if k is 1, if k is 1, what power of x do you get? You get lambda minus 1. Well, there's some food for thought. I'm just querying a little bit. How do you go about finding what? See, we know what. How do you know what alpha naught is? It doesn't really matter, I guess. It's just the ratios that are important. All right. Okay. So if you know k is 1, you know what AK of 3 is. If you know what A naught is, you know what A2 is, and so on. And you can keep ratcheting up. And you use these two equations to help you find the next one. So in other words, you can find all these terms, AK, and you can plug these. Once you know the AK, you can plug them in here, and that gives you. Well, you plug them in here, and that gives you the so-called Legendre polynomials here. Once you know what these are. All right. Now, so you have two series. This one for alpha is naught, and you have this one for alpha is 1, and so for the alpha is naught, you get that corresponds to even powers of x. I think some of these coefficients disappear. Yeah, I need to. Yeah, I'm not. I'm not an expert in Legendre polynomials. Yeah, I haven't studied this. Okay, so there are two solutions for different. Alpha is 0 and alpha is 1. I'm suspecting now that some of these coefficients may disappear, depending on whether alpha is 0 or 1. Alright. And so you get if alpha is 1, you get a series here where the powers of x are odd. Is that right? Yeah. So these powers here will be even for when alpha is 0, and you will get polynomials where the powers here are odd when alpha is 1. Maybe you should check that out. Give it some thought. I haven't done it. Alright, now can you see whether alpha is 0 or alpha is 1, that as k gets very large, now this is the kind of thinking behind the correspondence principle. So when we take a limit, now as k becomes very large, can you see that this term here becomes approximately 1 in the limit as k gets very large, and similarly here, because if k is very large, plus 1 doesn't change anything, plus 2 doesn't, and minus whatever, I mean, that's negligible. You can forget about that. So effectively, you've got k squared over k squared, which is pretty well 1. So as k gets very large, both right-hand sides here become effectively in the limit 1, the value 1. And I've run out of board, but we will use that limit in the next session. So quite a couple of loose ends there. If you can go stew about, like knowing these two relations for alpha is 0 and alpha is 1. Why do you get terms, even terms for the k here, or odd terms for the k here, for this polynomial? Why is that? That sort of question, right? I'm really curious. I wonder, I know about, at this stage, very early on in the whole deGarisMPC lecture series, and if I stay alive for a long time and I continue doing this, I'll probably do hundreds of courses. So I'm wondering what kind of following I would have in a decade or two from now if I'm still doing it. But at the moment, we're only halfway, pretty well, a bit more, halfway through the second course, just the second. And I have a following, meaning people, every time I add something to the website, an email is, those who are watching probably know, an email gets sent to you telling you this. So you're probably getting lots of emails every day, probably getting sick of them. But I have about 60 people who are following it in that sense, that they've chosen to be a YouTube follower. So that, they get notification every time I add another video. So I'm wondering how many of you are really studying this stuff. So there are quite a few homework questions in the last few sessions there. Okay, so next session we'll just continue on in the mathematics of the Legendre equation, and then later we'll come back to the AngularMmntm eigen equation and use the knowledge that we're gaining at the moment on how to solve the Legendre equation and generate Legendre polynomials.